So how would you implement softmax function? We're going to have a simple explanation on the math behind it. Of course, what is a softmax? It is a function that is used in machine learning, neural networks, to map a vector of real numbers as the input, and for the output you want to have a probability distributions. One common usage is like multi-category classification. For example, in computer vision, you might want to tell the type of flowers or the handwritten digits in MNIST, or in the NLP context would be maybe the sentiment analysis, right? Say if the mood is happy or sad, different kind of a classification. And if you have multiple output, right? So that would be a probability distribution. Now let's look at the math behind it. All right, so here you do have an input, which is a vector of n elements with certain values. By definition, your output is a vector of probability distribution, which means everything should add up to 1. That would be the probability distribution. In the numerical digits, handwritten 0 to 9, you would have 10 different classes. So you have a vector of 10 with probability. Now, if the probability on the first element is very high, you say, oh, that's more likely a digit 0, for example, right? So here, you notice this quantity here. On the bottom is the summation of all the exponential values. And here is the ith element of it, right? So, of course, if you add, this is the ith element of the output vector. If you add everything up, it's going to be sum up to 1. That is a valid probability distribution. Okay. Again, it is used in classification models and also in the attention modules in the very popular transformer models where you have softmax in the encoder architecture, right, of the transformer. You actually try to implement this. For example, you want to implement your own softmax in your library. You do not want to directly use this. Rather, you want to subtract the max value of it and then do the math. And what is the reason for that? Is actually for numerical stability. By doing so, we avoid dealing with potential case of overflow or underflow for some extreme values. Now, if you subtract the max, the benefit here is that you make the numerical more stable. So subtracting the max in this calculation here would not change the value of the output, okay? But the benefit here is to gain the numerical stability, so the calculation is more accurate, right? Remember, your computer is not theoretical math, right? When you do things, it's going to have numerical errors, right? So you need to be careful when you try to turn your math formula into a computer code. This is just one example. Accumulation of errors. Now this happens in the neural networks also, right? So you may have quantization where you introduce errors if you have a finite precision arithmetics, right, versus full precision floating number operations, right? So that's an interesting subject for those of you who one day may be an expert in the area of what is called numerical computation, right? That's really important in some of the physics, math, and other fields. So that's math behind it. If you would do Numpy, which is a Python package for numerical computations here, for those who are not familiar with Numpy package, it operates on the vector, so it will do element-wise, exponential here. Now with here, we just subtract the max, right, and then do the mathematical calculation here, right? So this would be the sample implementation. Thank you for taking the time to watch this video. Please subscribe to the channel for interesting math problems, or in this case, a combination of math and neural networks. Thank you.